in the Earth's crust slashes across 700 miles of California. The San Andreas Fault. It borders both San Francisco and Los Angeles and creates one of the world's most dangerous earthquake zones. Scientists are racing to find ways of predicting the next disastrous movement of the fault. When will the great earthquake strike California? California is famous for its warm and sunny climate. Its diverse lifestyles and spectacular vistas are as varied as any other land on Earth. Much of California's rugged beauty derives from violent earth upheavals, the product of a phenomenon called faulting. Deep cracks or faults in the Earth's crust scar the state from one end to the other. Of these, the San Andreas Fault is the longest and most dangerous. At 6 a.m. on February 9th, 1971, Californians were jolted into awareness of the powerful forces that molded their state. A sudden earthquake just north of Los Angeles caused massive devastation. 50 people were killed in the collapse of 2 hospitals. Since the quake was of only moderate size, engineers were shocked by the heavy damage to supposedly earthquake-resistant buildings and freeways. The Richter magnitude was 6.6, releasing several hundred times less energy than the San Francisco earthquake of 1906. Had the shaking continued for another few seconds, the San Fernando disaster would have been far worse. 2 dams holding 7 billion gallons of water threatened 80,000 sleeping people. When the dams began to collapse, only the abnormally low water level prevented catastrophe. Geologists soon pinpointed the quake on a minor branch of the San Andreas Fault. The main spine of the fault hadn't even moved. The San Andreas Fault system is part of a grid of faults, mountain chains, and trenches in the ocean floor. These features mark the boundaries between huge moving slabs of the Earth's crust called plates. Carrying continents and oceans with them, the plates float on a hot liquid layer of the planet. Along the fault in California, 2 plates slip and grind against each other due to movement deep within the Earth. Dr. Tim Hall has studied the San Andreas Fault for 15 years.
I visualize the San Andreas Fault as a 700-mile-long vertical curtain of clay that runs the length of California down to a depth of about 10 miles that separates 2 moving plates from each other, the American plate and the Pacific plate. In places along that clay boundary, the fault can move along year by year, and we call that creep. In other places along the fault, the rocks are stuck together, locked. A large amount of energy gets stored in these surface rocks, which is released periodically by sudden large earthquakes.
With its many branches, the San Andreas cuts a broad swath through California from San Francisco, Oakland, San Jose to Los Angeles. All are in fault zones. 15 million people are vulnerable. We shall travel along the fault, seeing places where the danger is great and observing sites where crucial research is underway. The trip begins at Southern California's Salton Sea. Repeated fault movement has lifted and exposed a reddish band of rock. The twisted cliffs were gouged by the fault's immense power. Nearby, the San Andreas has made pockets of groundwater. Lines of palm trees and brush mark the fault's passage beneath the bleak sands. Outside Palm Springs, 2-mile-high mountains were thrust up by millions of years of fault movement. The fault skirts the Los Angeles basin. Its numerous sub-branches, including the one which shook San Fernando, threaten more than 10 million people. North of Los Angeles County, the fault carves a broad valley. Near Palmdale, Dr. Kerry Seed dug into the San Andreas and found a treasure trove of prehistoric earthquakes. Using carbon dating, each event is identified. The fault goes down through many distorted layers, which mark earthquakes going back to the time of Christ. The intervals between major quakes range from a maximum of 300 years to only half a century. The earthquake of 1857, largest ever recorded in Southern California, shows up as a sand blow, where sand and water spouted from the earth in an eerie fountain. Trees along the fault had their roots sheared during the quake, causing growth to slow abruptly at the 1857 ring. In 1975, researchers found that a broad area of desert along the fault had risen about 1 foot during the last 15 years. They began a massive survey program to monitor this Palmdale bulge. Survey teams worked their way tediously up from Los Angeles, measuring the land level. Ominously, part of the bulge recently subsided. This pattern of uplift and collapse also happened before the devastating Alaskan and Chilean earthquakes. In Southern California, the pattern occurred once before without an earthquake. Does the Palmdale bulge reflect a harmless cycle or warn of a major jolt on the San Andreas fault? North of Palmdale, geologists drilled deep into the fault zone to measure the stress on underground rock. In hope of finding a new way to forecast earthquakes, the researchers pumped water into the drill hole. They increase the pressure until the rock breaks. Knowing the natural strength of rock, they measure what added stress it is under from the earthquake fault. They have found that rock in the fault zone is cracked, water saturated, and close to the breaking point. Further north, the San Andreas cuts through hilly desert country. In the stark and desolate Carrizo Plain, fault features are clearer than anywhere else. Most ground movement here occurs during large earthquakes in jumps of several yards parallel to the fault. The last of these took place in 1857. The quakes also cause the ground to move vertically, forming ridges along the fault. Repeated slippage has diverted streams along the fault. According to carbon dating, this stream bed moved 125 meters in the last 3,400 years. The Pacific Plate slides northwest, averaging 2 inches a year. At this rate, in 5 million years, it will carry Los Angeles past the Carrizo Plain on its way to San Francisco. Midway between Los Angeles and San Francisco on the Pacific coast is the Diablo Canyon nuclear plant. The facility was originally designed to withstand an earthquake on the San Andreas fault of Richter magnitude 8.5. During construction, however, geologists discovered a nearby fault offshore, the Hosgri Fault. Ralph Rana is a county environmental worker who lives near the site.
I'm opposed to the nuclear power plant at Diablo Canyon because there's an earthquake fault running 2.5 miles from the plant itself, and that fault happens to be 250 miles long, and it's a major earthquake fault in California. A very large earthquake in 1927 of magnitude 7.5 occurred on that fault. A magnitude 8 earthquake is also possible on the Hosgri Fault.
Richard Davin represents the plant's owner, Pacific Gas and Electric.
There are earthquake faults around Diablo Canyon, of course. There's a San Andreas fault 48 miles away, but there's a Hosgri fault which is closer, and that's the one that's been of the major concern in the last several years. And as a result, it's been the most thoroughly investigated fault, probably in California outside of the San Andreas, and we have designed that plant to withstand the maximum earthquake that could ever be expected to occur on that fault.